Hi everyone. So today we're going to work on Pythagorean Theorem and some special right triangles. So I'm pretty sure we've done this in the past, like in geometry, but it doesn't hurt to review. So we're going to be involved solving applications involving the Pythagorean Theorem as well as some special right triangles. So let's review. Pythagorean Theorem is in any right triangle, and that's the key. We have to remember that it's only for a right triangle, that A and B are the lengths of the legs, and C is the length of the hypotenuse. So we also need to remember that the hypotenuse is opposite the right angle, and the other two are the legs that form the right angle. So it's A squared plus B squared equals C squared. Now, when we're solving a Pythagorean theorem problem, we need something called the principle of square roots. So it says for any non-negative real number, if x squared is equal to n, then x is equal to the square root of n or negative square root of n. So there might be two possibilities, but you got to remember that we are talking about lengths of triangles, so we may not be using the negative solution. All right. Okay, so we have a baseball diamond is a square. So I have a picture right here for us. Each side of the square measures 90 feet. And suppose the catcher fields a ball while standing on the third baseline 10 feet from home plate. How far is the catcher's throw to first base? And we want to give an exact solution and an approximate solution. Okay, so here's the picture. Now, this is kind of hard to see, but here's our right triangle. So I'm going to redraw that up here. That we have a right triangle. Here it is. Where this is 10 feet. Here's our right angle. This is 90 feet. And we want to know, here's our catcher. Here's my little guy here, and he's going to throw the ball to first base, which is over here, and we got to figure out what that distance is. All right, so we just have to be concerned is like, which one are we solving for? So keeping in mind that the distance is opposite the right angle, so that's going to tell me that we're going to be a squared plus b squared equals c squared. Okay, so 10 squared plus 90 squared is equal to c squared. I know this is 100 plus 8100, I believe, equals c squared. So that's 8200 is equal to c squared. Now, since we're solving for c, we're going to square root both sides. That's the new part right here, square root, square root. And usually I'm very adamant about the whole plus and minus concept. But because these are applications, we're only going to work with the positive solution. So I'm going to pull up my calculator. Square root, okay, so second square root of 8200. Okay, and this is going to give us our approximate solution, so 90.55 feet. Okay, so C is approximately 90.554 feet. Forgot my last decimal. Okay, so now we're going to have to break this down because I want an exact solution. So 8200, I'm going to break him down into 182. And I think it's about as good as we're going to get. So square root of 100, square root of 82, 10 square roots of 82. So it's approximately 90.554 feet, or an exact solution would be 10 square roots of 82 feet. Okay. All right, so let's try the next one. The base of a 40-foot long guy wire is 15 feet from the telephone pole that it anchors. How high up the pole does the guy wire reach? And again, we want an exact solution and an approximate solution to 3 decimal places. All right, so here's our picture. A guy wire, by the way, is like a wire that they use to hold down, almost like a tent wire, tent stakes. Like if you're going camping, they use those wires. Or sometimes you see them on brand new trees, saplings, and they put the wires on them so that they stay in place. That's what a guy wire is. Okay, so we're interested in height. Here's my right angle. 40 feet is opposite that. So we're still going to use c squared, a squared plus b squared equals c squared. Okay, so we're going to have 15 feet squared plus 40 feet squared is equal to c squared. Okay, I think 15 feet is 225. 40 would be 1600 equals c squared. So 18. Ooh, nope, I messed that up. Did some bad math. I screwed up. Even though I said it was opposite the right angle, I didn't put it in the right place. Remember, opposite the right angle is C. I don't know what I was thinking. All right, so this is 225 plus b squared, which is 1600. Okay, so we have to solve for b squared, so we're going to subtract 225 from both sides. Okay, so 1600 minus 225, 1375. Okay. All right, so we're going to want to square root that. Okay, so we get the square root of 1375. Okay, so we're going to have to break down 1375. All right, 1375. We know it's divisible by 5. So that's 2, 7, 5. Let's do another 5. So that's 5. 55. And this is 5 and 11. All right, so we need a pair because we're going squares. So that's it. Square root of 25, square root of 55, or 5 square roots of 55. So our exact answer is 5 square roots of 55 feet. And our approximate answer is square root of 1375, 37.081. 37.081 feet. Okay. All right, so don't do what I did and make sure everybody's in the right places in the formula. Okay? All right, so special triangles, and again, I feel like we've been here, done that. So our special triangles, there are 2. So when we know certain things about the triangles. So the first one is a 45, 45, 90. So think of it as a square that gets divided in half. So if I make a square here, which means that all 4 angles are right angles. That's a really bad square. So if I divide it in half, these guys are both 45. So I have an isosceles right triangle. Okay, so let's look, since both of these sides, these guys are both the same, let's use our formula. So if I use a squared plus b squared equals c squared, okay, but 2 of them are the same, so I'm just going to go a squared plus a squared. Okay, so 2a squared equals c squared. And I want a square root to find c. Well, the problem is that I can take the square root of a squared. So a square roots of 2 is equal to c. So these guys is the square root of 2 times a, or I would refer to it as the square root of 2 times the leg, because that's how I was taught, back in the Stone Age. So let's see if we can do it without doing Pythagorean theorem. I apologize. One-legged isosceles triangle measures 7. Find the length of the hypotenuse and give your answer an exact and approximate decimal. Well, if one leg is 7, this is also 7, which makes this 7 square roots of 2. So C is 7 square roots of 2. So approximate would be 7 square roots of 2. 9.899. we go. All right, so the beauty of the 45, 45, 90 is that you don't have to do a whole lot of work because you know there's a relationship. Okay, so the hypotenuse of an isosceles right triangle is 5 feet. Find the length of the leg, given the exact answer, and approximate. So that means that, okay, so C, remember, is A square root of 2. But we know the answer is 5. So I'm going to divide by the square root of 2. All right, so yeah, they don't like that. That's not going to work for us. So we're going to have to rationalize that denominator. So we're going to do 5 square roots of 2. And remember, we want to make it a perfect square on the bottom. So I need to multiply 2 by 2 to make 4 to be a perfect square. So I'm going to multiply straight across. Or 5 square roots of 2 over 2 is our exact solution. Okay? And that's for A. And our approximate solution would be 5 times square root of 2. And then we're going to divide that answer by 2. And I got 3.53. And we're going to round to 6. Okay. All right, so again, as long as you know the relationship, it's pretty easy. All right, so here's our kind of rule. The length of this hypotenuse in an isosceles. Oh, I'm so sorry. Isosceles right triangle, or 45, 45, 90 triangle, is the length of the leg times square root of 2. So C equals A square root of 2. Okay, and there's our little picture. Now we can do the same thing with 30, 60, 90. So kind of like a 45, 45, 90 is like a square cut on the diagonal. 30, 60, 90 is a equiangular equilateral triangle cut in half. And that's what this is. Okay? So if everybody is the same length, okay? So each side, let's call it 2A. And then we divide it in half. That means each one of these denominators, or these sides, are both A. Hypotenuse is 2A. Height, we'll just give him a call as B. Okay? All right, so where is this going to come from? Okay, so let's do our Pythagorean theorem. So A squared plus B squared is equal to C squared. So A squared plus B squared is equal to 2A squared. So A squared plus B squared equals 4A squared. Okay, so I guess I can subtract A squared, 3A squared. So I guess we can figure out what B is. And we can take the square root of A. So now everybody's in relationship to A. I have A for the smaller side, 2A for the hypotenuse, and A square root of 3 for the longer leg. Now keep in mind the shorter leg is opposite the 30-degree angle, the longer leg is always opposite the 60-degree angle, and the hypotenuse is always opposite the 90-degree angle. All right, so let's take a look at how this is going to work for us. The shorter leg of a 30, 60, 90 triangle measures 8 inches. There's our picture. If there's no picture, by the way, you should always draw one. Anytime you're doing with a triangle problem, always draw a picture. Find the lengths of the other sides. Give an exact answer, and where appropriate, an approximate answer to 3 decimal places. All right, so let's look at our relationship here. We know that C is going to be 2A, and B is A square root of 3. Okay, so 8 is A. Okay, so A is 8, B is 8 square root of 3, C would be 2 times 8, or 16. Okay, and this is in inches. Okay, now, the only one we need an approximation for is the 8 square roots of 3. Okay, so 13.856. There we go. All right, let's try one more and then we're going to call it a day. So we have the longer leg in the 30, 60, 90 triangle is 14. Find the length of the hypotenuse and give an exact answer and an approximate. Okay, so this guy is 14. Okay, so remember, he is a square root of 3. C is 2a, and down here is a. Okay, so we know that, oh wow, I guess I better figure out what a is. Okay, so we're going to divide by 3, square root of 3. Okay, now before I rationalize my denominator, I'm going to find our hypotenuse. Okay, so that's going to give me 26 over the square root of 3. Okay, so I'm going to rationalize that. So I'm going to multiply. What am I going to multiply 3 by to make it a perfect square? Well, another 3 would be great. Okay, we're going to multiply straight across. So 26 square roots of 3 all over square root of 9, which is 26 square roots of 3 over 3. And I would love to take 26 and divide it by 3, but it doesn't work. So our C is 26 square roots of 3 over 3, or, did I do my math? Why did I have 28? Oh, that's because I copied the problem wrong. I did 13 and the actual answer is 14. Well, that's, can you tell I'm tired? I don't know why I'm so tired. So this is 28 over the square root of 3. Square roots of 3 over 3. Okay, so let's find the approximate value. So 28 divided by, I guess we can just do it this way, square root of 3, to get the approximate. So, or 16.166, and this is in centimeters. There we go. And here's our rule for 30, 60, 90s. All right, guys, let me know if you have any questions. I feel like we've been here and done this, but it doesn't mean that we can't go over it and that it gives us a really good refresher on the Pythagorean Theorem and special triangles. Again, let me know if you have any questions, guys. I'll talk to you again real soon.